Once again, my name is Keith Weber. I think I know probably everyone that is connected right now. And I'd like to talk to you about a project that has been going on here at the GIS Center. Really, it started in 2012, but there was a bit of a hiatus on that project for about a couple of years, 2019 until 2022. And the project that I'm referring to is what you're seeing up on the screen there, the NASA Recover, now called NASA Recover 2.0, post-wildfire decision support system. This is something that I developed, my brainchild, if you want to call it that, in early 2012. I had a lot of great help from colleagues at NASA Goddard Space Flight Center, and now also working with colleagues at the USDA Forest Service GTAC. You see Brad Quayle is one of my co-PIs on this project, and the GTAC team is down there in Salt Lake City. So let me start with this. Let me answer the question, what is Recover 2.0? Well, Recover 1.0 was a purely server-based platform for post-wildfire management and long-term monitoring. Recover 2.0 is much more a cloud-based platform serving those same purposes. So that was the big transition that we made, was to push as much as possible into the cloud, which then sets up Recover to have an easy transition to U.S. Forest Service GTAC following the end of the grant period from NASA. Now, one of the reasons why I wanted to make this presentation to the Tech Talks, which really focuses on GIS and spatial technologies, the reason I wanted to do this is because we're coming up into the fire season, the wildfire season, even though around here in Pocatello, you may not believe it because it snowed here yesterday, right on May 1st, had some snow on the ground. It's pretty cold, but you know how things work. Summer will just come in, things will get very warm, and there will be a wildfire season. It may not be very bad, it may be terrible, I don't know what's going to happen. But oftentimes, what does happen in the aftermath of a wildfire, or even during an active wildfire event, is that GISers, us, we are asked to support emergency managers, support them with maps, support the post-fire rehabilitation teams with maps and spatial data and spatial analysis. So I wanted to make sure you were familiar with NASA Recover, so you know a great place to start to assist those emergency managers and land managers that you may be asked to help out. So Recover 2.0, just like the original Recover, is and will always remain a customer-driven, customer-centric decision support system. You can see there that our customers, our agency and organizational wildfire and land managers, as well as, you can see that, land managers at state agencies, as well as county emergency managers. Enhancements provided by Recover, even the original Recover, number one was very rapid spatial data acquisition specific to a post-wildfire event, or specific to a wildfire event. We produce what's called data packages, and every individual wildfire across the western United States of any particular size will have a data package built for it by our servers and the cloud servers, so that it's ready for the land managers, fire managers, as well as the GISers to support those folks. Another major enhancement provided by Recover is its cross-organizational collaboration. And Recover literally breaks down or broke down silos. What we saw years ago was that there was a lot of wonderful and very important data that may be in the hands of the Forest Service or the BLM or a state agency or whatever. But a lot of wildfires are multi-jurisdictional. In fact, I'll say most wildfires are multi-jurisdictional. Yes, the majority of a fire may burn on BLM land, but it may also burn partially on Forest Service lands, maybe some state lands, maybe some private lands. They're always, almost always multi-jurisdictional. So the silo needs to be broken down. All of those parties involved in the wildfire and the post-wildfire planning, they need access to the data. And ideally, they're all using the same data. So Recover provides this common operational picture. That data package provides all of the same data layers. Everyone has access to the same data layers. They're all current, authoritative data layers, and they are all in the same spatial reference system, really ready to go. Now, that may not be too important to the GISers, but to people who are not really GIS experts, GIS professionals, having things in an analysis ready to go format is really a big time saver and pretty important. So we made sure that we do that with the Recover system. Our data architecture, we have what we call base layers. It is wall-to-wall coverage of 37 base layers across this entire area, these 11 Western states. We're using authoritative data, and oftentimes we are value adding to those authoritative data to make them better. How are we doing that? What are we doing? Not changing the data, but making it so that it communicates, transforming the data into information. That's really important, so that people can get up and running, understanding the data, understanding those actionable information as quickly as possible. Really, a lot of this is allowed to happen, if you want to call it that, or is supported through what we call the large fire trigger. This is something that I started developing years ago. Jeff May, who worked for me, actually made it happen. Took my vision and my little model builder tools and converted those into a very nice Python script. Did a wonderful job. And now we've had Cole Rosner and Dr. D. Wu working on the same thing, building, rebuilding, improving that same large fire trigger. That large fire trigger script actually sits on one of our servers. It ingests data from the cloud, pushes data back out to the cloud. But what it's doing is every night at about 1 a.m., actually it's in the morning, it looks for new wildfires that have not yet been processed by Recover. Or it could be an active wildfire that is burning and it has changed since we last processed it, since the day ago. And then it goes through and processes that data, gets it ready for you to make use of, fire managers, our customers to make use of. And normally it does all that work in a couple of minutes, matter of minutes. If there's a lot of active fires that it needs to process, it may take it 45 minutes or so to go through all those wildfires across the Western United States. It bundles up, as part of the process, it bundles up these data packages that I alluded to earlier. It's a zip file containing those 37 base layers clipped effectively to the wildfire, what we call the wildfire area, not necessarily the wildfire perimeter. I can explain that later. We are also leveraging Esri's ArcGIS Online, the cloud, as well as Portal enterprise servers. Here's a glimpse at these base layers. We have a bunch of vector base layers, critical infrastructure point data, the fires, past fire histories, geology, habitat, lots of soils information. And this list here gets updated, or I should say refreshed, every year. So every one of these data layers was reviewed, took a look at, and myself and my students took a look at each of these data layers, checked, did things change? And if they did, we made an update using that same authoritative data. Like, for instance, the NRCS put out some new Surgo data. So all of these layers, these soils layers, have been updated. Lots of these layers have been updated, again, this year in preparation for the 2024 wildfire season. Plus, there's some additional web services that we provide straight through the layer files that are part of that same data package. So the data package will provide you with a geodatabase, all these different feature classes, points, lines, and polygons. Plus, it will provide you with a rasters folder, and you will get land fires, biophysical setting, existing vegetation cover, existing vegetation type, this NDVI data that I'll explain to you here in just a little bit, what all this neat stuff is, and a lot of topography data, all different ways of looking at and understanding the terrain. Web service layers, yeah, we are consuming, and in actually many cases, this is where we're value adding also, the fire severity for those wildfires that we are helping out on. So a wildfire severity layer will show you, in very similar to an NDVI, there will be a number, an index assigned to those raster pixels, where 0 effectively is this area hasn't burned, and the higher the number, the larger the number, the more severe the fire is believed to have burned in that or across that pixel. That's called the, and I've simplified things quite a bit, but it's called the differenced normalized burn ratio. So what we do is we grab or download, acquire the DNBR data provided by the BEAR teams, U.S. Forest Service principally, but others. We grab those and then we make those into a image service, mosaic dataset image service hosted at the GIS Center. We also are bringing in debris flow models that are produced by the USGS through their landslide hazards program. We're bringing in live streaming stream gauge stations. That's a neat layers point feature class. You can click on that layer. There's a hyperlink inside of that that will then jump you to open up a web browser window for you, and you can see current stream flows at that stream gauge station. And we're using a lot of the USGS National Hydrography data set data directly or value added, most of it directly. Plus, our data package includes a toolbox, and one of those tools allows you to quickly create an automated executive summary report for that particular fire that you just downloaded. That report, about 4 or 5 pages based on the size of the fire, and it'll tell you things like the number of people, the population that were impacted within that fire area. Not necessarily, again, within the fire perimeter, but inside what's called the fire impacted area. And then, of course, we also have, and this is what the NDVI stuff was all that I was alluding to earlier, we have the long-term post-fire monitoring that we have built, enabled using NASA satellite imagery, specifically Landsat. What we did, and this took a while, step one in 2023, last year, we developed a decade-long baseline of NDVI from Landsat imagery. Again, this is across those 11 Western states, 10 years worth of data, and that is 18,000 scenes of Landsat data, processed, downloaded, acquired. Step two we took all that NDVI data and created a multi-dimensional image service within a Mosaic data set of all those data. We didn't kick out any data as long as it had less than 10% cloud cover. We used that data, and then we made that into, as you can see, an image service. And that image service can be used in a web map or in the desktop. You can connect up to it and use that. Step 3, we developed a web interface and a tutorial to help you know how to use the NDVI Baseline. That's what we're calling this particular tool or capability. And then step 4, and this just happened. This has just been finalized and we know it's working. We have set up an automated collection for new or current NDVI imagery within the same fire area. Now, the way that that works, really kind of interesting. Dr. D. Wu built that. Again, it's based inside of ArcGIS Pro, but it connects and uses both Google Earth Engine and ArcGIS Pro within the same Python scripting environment, a special environment that was set up just for this. Person will simply zoom into the wildfire perimeter, the area of interest, let's say, then step through the tool. Essentially, number 1 is logging into your Google Earth Engine account. Number 2 is what is the date on which you want to have the script start looking for new NDVI data. And step number 3, where do you want the new NDVI data put on your computer? Doesn't go out to a Google Drive or anything. It writes it straight to your computer. Then you let it run. And in a couple of minutes, literally a couple of minutes, it will complete all that process and bring down, copy down to your computer that data for that area that you just specified. Now what you can do is you can compare the current NDVI that you just downloaded with the decade-long NDVI baseline. Now, the NDVI baseline provides you with the mean or average NDVI over 10 years, median NDVI, minimum, maximum, standard deviation, and then, to make it even more complicated, I guess, we have applied the standard deviation to the mean to give you the upper and lower bound at 95% confidence intervals, right? So that's kind of some important information that you can use to see how that fire area is recovering back to pre-fire conditions. Now, you'll see a couple things here. Keith, why did you bold the word median? I did that more or less as a reminder to me and to draw your attention to it, but to let me know that I need to explain this just a little bit. And because this is a decade-long data set, data cube, if you want to think of it like that, it includes, can't help it, it includes past wildfires. And when a wildfire burns somewhere, let's say right over here, well, the NDVI, shortly after that wildfire burns, is going to be really, really low. And because of that, the mean for that same area is going to be it's really going to be affected when you run the mean. Whenever you have very high or very low values, the mean is pulled really, really easily. The median is a better statistic, especially for something like this, because it's considered resilient to those very high and very low. Sometimes they're outliers, but sometimes not. But it's resilient to those very, very high and very, very low values. So I recommend that users compare current conditions to the median conditions. For that same reason, disturbances are dropping and making very, very low NDVI values. We're not providing minimum. It's kind of useless. But you will see maximum NDVI, and then, of course, the upper and lower bounds at that 95% confidence intervals. To use Recover, you can simply open a browser window to go to our web page. I'll show you that here in just a little bit. You can use our experience builder. You can use our dashboard. I know that the dashboard is probably the most popular. And you can start anywhere you want. You can start here, you can start here, you can start there. They all interlink and interconnect to one another. But I will go ahead here in just a moment, and we'll do a little test drive. So let me get this started. Okay, I hope that you're now able to see the dashboard up on the screen. This is our NASA Recover dashboard, and it is current. Everything is absolutely currently running right now. There's our Western United States kind of highlighted area, and you'll see that so far this year, there have been some wildfires across the Western United States. And if you want to use or view the data for any of these particular wildfires, let's take a look at Double Creek. Double Creek is not a current wildfire. This is one of our demo wildfires. It burned a while ago, 2022, and it has a red highlight behind it because it is a mega fire. It is larger than, it burned more than 100,000 acres. So I go to my Recover Quick List, click on it, and what's going to happen here is it is going to zoom in to the wildfire area. Now, the only reason why you saw that little bit of a lag is because of Zoom. Zoom does consume quite a bit of bandwidth. If you're using this live yourself, using it in your own browser, you will not get that much lag that we just saw. I can then click on Double Creek, and there it says download the Recover data package. I'm going to go ahead and it says view, but it's just going to download it, and that's what it's doing right now. It is downloading that data package, and I think it's actually done already. Gee, isn't that something? Well, there's more to it, right? I can come over here to my layers, and I can look at any one of these 37 layers that we already talked about, right? I can go in and take a look at all these. I can do a lot of data visualization. I can, let me go ahead and bring in something that might be interesting here. Let's look at some land cover. I'm going to turn on this biophysical setting. There it is. And I'm going to click on it. What is that, land cover type right there? I'm going to move over to the biophysical setting, and I learned that this is Northern Rocky Mountain ponderosa pine. Okay, I'm starting to get a feel for the area that was burned by this wildfire, and I can continue exploring all these different data. Obviously, just inside of a browser. You don't have to be a GISer. You do not have to have ArcGIS, any of that stuff available to you. Now, if you do, obviously, you can make it an awful lot more powerful, and that's what the data package is for. The data package is absolutely ready to open up and get used or be used inside of ArcGIS Pro. Now, the other thing, we know that some folks can visualize spatial data better in 3D. So we built a 3D viewer for this same stuff. Let this launch up here, and I'm going to go ahead and I'm going to kind of jump ahead of this. I'm going to zoom into the same Double Creek fire we were looking at. And, you can do all the stuff that you normally can do. Hope that's playing pretty good without too much lag inside the Zoom window for you. Lots of things we can do, kind of some fun stuff. We can look at an elevation profile. I'll let you do that if you want to do that sometime. And of course, we can turn on and off all of these different layers. Couple of things that you can also do is we can jump out to the dashboard. As I said, these things are linked to one another. I'll go back to my little hamburger menu here. All the metadata for every one of these layers is available there. There's a step-by-step tutorial, take you through all the different capabilities, lots of different capabilities of the NASA Recover platform. And another one I'll show you is, let's say you don't want to mess with the dashboard. I know the fire that I need to deal with. I know exactly what I want. I know it's called this, that, and the next thing, whatever. You can just jump out to our server and just bulk download all the stuff that you want to. So we provided all these different things for you. Let me jump out here real quick to show you I've already shown you the dashboard. There's that same bulk download link. This is our web page for the project. If you just want to use our services directly, there they are. There's a link to all of these things available to you. A little bit of documentation, all the links, the place, the authoritative source where we got this data, et cetera, et cetera, et cetera. So I want to set you up. If you're going to be, or if you need to assist your community in upcoming wildfires that may happen this year, you can make use of Recover. No password needed. Absolutely wide open to anyone who needs to use this sort of thing. So we are darn near the top of the hour. I am going to open the floor for any questions that you may have.